Good morning everyone, I am Mr. Ish. Thank you for joining me. Inscribed angles, this video over here. We have a circle with two triangles that are inscribed. Here's a center. We have to find all the angles. You know the angles would be those which are pertaining to these triangles. If you're given this angle right here, 80, you have the center. Each of these lines extending from the center to the outer circumference of the circle are all radii, which means all of these sides must be equal to each other because the radius is always the same no matter which aspect of that circle it touches, originating from that center. If that right there is 80, you know this right here, by means of supplementary angle definition, you know what that's going to be. That's going to be 100. If that's 100, then these two must be equal to each other, these angles being equal, because this would be an isosceles triangle. You would have two angles here adding up with that third 100 to equal 180, and the only thing those can be would be 40-degree angles. And that would be 40, that right there would be 40 as well. 40, 40 and 100 will give you that 180. If this right here is 80, then you know this of course is 100. Its opposite angles are equal. Here's an 80 as well, opposite angles. Then you know this must be 40 as well, and that must be 40 as well. And the question has been solved. The most crucial part of this is specifically this part right here, from the center to the circumference. Any of the lines drawn are radii, and the radii here in this case are generating isosceles triangles. They're all 40-degree angles of that triangle. So you have a triangle over here which is 40, 40 and 100, and the question has been completed. For our second question, let's look at this depiction over here. We have a circle from which we have a line tangent to it. This right here is a tangent line at this point right over here. Over here we represent a center of that circle. We know this segment AB and CD are parallel to each other. Given this angle, we have to find everything else. How would you go about doing that? The first thing you can do is just notice the fact that from the center to the point of tangential contact with the tangent line is always 90 degrees. It's 90 degrees no matter what. So we've developed the fact that these are 90 degrees. If CD and AB are parallel to each other, then this of course is 90 degrees as well. We've developed those. If this right here is a 40, that right there is a 90, you know what that's going to be. That'll be a 50 degrees. And then you know you can very easily see corresponding angles develop here. If this right here is 50, and then all of this right here is supplementary angle equaling to 180, two angles equaling 180, then you know that's going to be 130. If that's 130, that's 90, you know what that's going to be. You can easily compute it, 90 plus 90 plus 130, and the difference of that from 360, and you'll easily get it, and it should really be 50 degrees, because this 50 degrees will correspond with this 50 degrees, and your question will have been solved. You have 40, you have 90, 50, 90, 130, 50, and 90, and those are your answers right there. One trapezoid develops, one right triangle develops in this particular depiction. The sum of all the angles in this specific triangle will equal to 180. The sum of all the angles in this trapezoid here will equal 360, and they indeed will be the case, and the question is good. And the answers are good too. And that's it for this video right over here. Have a great day. Thank you for watching. Bye.